Good day, everybody. Today we're going to do lesson plan number 4 of grade 6, term 2. Our topic is multiplication and prime factors. Our link to the DBE workbook is worksheet number 28. So there you see it. We go back to the lesson plan. This is the link to the CAPS. Here's some interesting facts so we can create an interest and a love for mathematics. Keep on asking those. Challenge them, ask them to bring some riddles to school. Then we're going to look at the dictionary. Now, the first, I'm going to read the dictionary words because it's very important for the rest of the lesson. So, a prime number is a number that can be divided only by one or itself without remainders. It must be greater than one. So, what does it mean? 7 can be divided exactly only by 1. 7 divided by 1 equals 7 and by itself. 7 divided by 7 equals 1. So what is a prime factor? Prime means main or the most important. So factors are the numbers that we multiply by each other to get a specific number. For example, 3 times 7 are the factors of 21 because you get 21 when you multiply 3 times 7. So in this case, 3 and 7 are prime factors because 3 is a prime number and 7 is a prime number. I want you to pause here and then just as an activity or prepare a few examples of prime factors. Okay, it's time to get the learners then. What we're going to do is we're going to do the mental mathematics. You're going to show it to the learners. They're going to answer it orally or they're going to write down the answers and we're going to pause. Welcome back. What we're going to do is we reveal the answers. You can pause again, mark it, and then we're going to carry on with the rest of the lesson. Okay, welcome. So what we're going to do is we're going to look at prime numbers first. So a very nice activity is where we have this number board. And what I want you to do is I want you to tell me which of these numbers are prime numbers and why. So pause it and then you can tell me your teacher or your parent. Well done. You notice that all the darker blue numbers are prime numbers because they can only be divided by themselves or 1. Okay, let's then go to the concept development. So the first example, what we're going to do is we're going to break down numbers to get them to their prime factors. Now these we call prime factor trees. Now in lesson week 4, day 4, we will do factors again more in detail. Okay, so let's quickly look at example number 1. So 4 is not a prime number because it can be divided by 4, it can be divided by 2 and by 1, and not only by itself or 1. So when we break it down, so we say 2 times 2 equals 4, and we know 2 is a prime number, so here it's already broken down in its prime factors. Let's look at 9. So 9 is not a prime number because we can divide it by 3, we can divide it by 9, and we can divide it by 1. But if we get the two numbers, if we multiply 3 by 3 and 3, it will give us 9. 3 is a prime number. So the prime factors for 9 is 3 times 3. Let's look at 12. So here we have 12, and what 12 is definitely not a prime number because we can say 3 times 4, 6 times, we can say 12 divided by 3, so 3 times 4, 6 times 2, 1 times 2, it can be divided by 12, it can be divided by 1. So in summary, 12 can be divided by 1, 2, 3, 4, 6, and by 12. So let's try it then. So 12, what if I got 12? Which two numbers will give me 12 when I multiply it? 6 times 2 gives me 12. So the 2, I know it's a prime number. But what about the 6? No, 6 is not a prime number because 6 can be divided by 6, by 3, by 2, and by 1. So what we do is we're going to now expand our tree and say 6. Which two numbers can I multiply to get 6? 3 times 2. 3, 2, those are both prime numbers. So the prime factors for 12 then is 3 times 2 times 2. You can also have something like 12 and you can break it down into 4 and 3. So I want you to pause here and then draw your own tree, but you're not using my example of 6 and 2. You're going to write there a 4 and a 3, and then you're going to expand your tree. Pause. Welcome back. You will see even though you got a 4 and a 3 here, you got the same results. You still got, for the 4, you still got 2 times 2 and you got your 3. Okay, let's go and look at something like 42. So 42, 6 times 7 equals to 42. I can break it then down the 6 into 3 and 2. And the 7 is already a prime number. So the prime factors for 42 is then 3 times 2 times 7. I want you to pause here and quickly explain each of these examples to an adult, and then unpause when you're done. Welcome back. So the next example, what we're going to do is we're going to use factors to multiply. Now again here, it's to do with a thinking process and different techniques that we're learning. Yes, I do agree. It's not always the easiest way to multiply two numbers, but it's more important to understand certain techniques. And therefore, it is important that we do them in grade 6 because these techniques we're going to start using in grade 7, 8, and 9 in algebra. Okay, so we got 547 times 42. So what we're going to do is we're going to break up the last number into its prime factors. So first we're going to say 547 times 6 times 7. So let's put brackets around them so you can see that relates to 42. And then again is we know 6 is not a prime number, so we're going to break it up into 2 times 3 times 7. And now what you can do your calculations on a piece of paper, or you can try to work it out in your head, but it's maybe easier to do it on a piece of separately on a piece of paper. So we're going to say 547 times 2, and we're going to get the answer. After getting the answer, we're going to multiply it by the next number 3. Getting the answer, we're going to take this then and multiply it by 7. So for these steps here that I'm highlighting, you can also use a calculator. So now what we have is we have 3,282 times 7. So we're going to use the distributive property. You can see we wrote it down like this. Remember the commutative property said that we could say 3,000 times 7 or 7 times 3,000. It doesn't matter which way we write it down. So in this case, we said we're going to multiply 7 with 3,000, 7 with 200, 7 with 80, 7 with 2. So we wrote it down in brackets like that. And then 7 times 3,000 is 21,000. 7 times 200 is 1,400. 7 times 80 is 560. And 7 times 2 is 14. And we added that up. If you can't add it up from here, remember again, you can go and break these further. The 1,000 and the 400 and the 50 and the 60 and the 10 and the 4 into making use of expanded notation and then add it up. What I want you to do now, I want you to pause, place a paper on this. So let me quickly show you. This is now, if you've got the printed lesson plans in front of you, you can place a paper on this. And what you do is you do the first step, then you reveal and check if you did it right. Do it, reveal, do it, reveal, do it, reveal, do it, reveal. And you carry on like this. Remember this step here, nothing wrong if you wrote 3000 times 7, 200 times 7, 80 times 7, 2 times 7, and you're going to calculate it. Okay, so what we're going to do is we're then going to scroll down and we're going to go to our worksheet. Again, the worksheet in the DBE book, or you can use the SA Teacher worksheets. And every time what you can do is you can go back to the examples if you want a clearer understanding of what to do. Then what we have is you're going to solve your problem, and then please do these because these are coming from old exam papers. And then we got some challenges on this side that you can use. That's also coming from papers or international studies. And then we come to the consolidation. If you ticked everything yes, you can carry on with the next lesson. Remember, in this case, we want you to try out this multiplication method because of the techniques that you need at a later stage. If you have any no's, you need to revisit, revise, or you need to contact SA Teacher.